Hello everyone. Welcome to the session, and today we will talk about OOPS or object-oriented programming. Object-oriented programming is a very important concept for interviews, and especially for the last round of interviews, I would say, like where you are given some functions and you have to complete or code those functions. Okay, so it is very important for that last round of interview after the DSA interviews are over. Okay, so generally after the DSA interviews are over, there is a last round called LLD or open ended or anything. The name can be anything, but in that round it generally revolves around OOPS concept, and you have to write your code using OOPS concepts, and basically you have to write a clean object oriented code. Okay, so today we will be talking about OOPS and the concepts, the basic concepts that are used in OOPS interviews. Okay, so basically that we will be talking about. So let me share the screen first of all. So we will discuss about five things today. Sorry, four things. That is classes and objects. Like what are classes, what are objects. Similarly, what is encapsulation, what is inheritance, and what is polymorphism. So these four things are basically the fundamental and the most important thing for the interviews. So first of all, what are classes? Okay, so classes are nothing but a set of entities. Like every class has some properties, some member functions. Okay, so for example, if we take the example that we will discuss today, so let's say we have a class called bank account. Okay, so before I dive into classes and objects, so let us discuss another thing, like what is the importance of OOPS. Why can't we write a simple code without using OOPS? Okay, so let's say you are writing a very big code, like it contains around 500 lines of code. Okay, so let me give an example. So let's say you have to print the number 10, let's say 5 times. Okay, so what is the most naive way of doing it? Print 5 times. Okay, or another efficient way will be like for means iterating over a loop and printing 10 for 5 times, right? But we can use do this using oops also, and the reason we can do this using oops, so let us take an example. Like let's say you define a variable called a, and the value of the variable is something like let's say uh, another constant plus 7. Okay, so let's say you want to change this the value of the constant for some specific reason. Okay, so if you are not using oops, let's say there is another variable called b, and it also uses the variable constant. Okay, so and the value of b is let's say 5. Okay, so let's say if the value of constant changes for some reason. Okay, and you are not using this constant, instead of using constant, so let's say if the value of the constant is 5. Okay, so instead of using the variable constant, so here you are writing 5. Okay, and here also you are writing 5. Okay, so now the value of a and b will be the same whether you write 5 or constant, right? So a will be 12, b will be 10. Okay, but let's say for some reason the value of constant changes due to the requirements of the code and something, so the value of constant changes from 5 to 6. So now to accommodate your changes, or now to reflect your changes in the whole code, you have to change values twice. That is, here you have to change once, and here you have to change once. Okay, but if you have written constant here only. Okay, so you don't means even if the value of constant changed from 5 to 6, you need not change anything except the value of constant. Okay, so that's means one of the basic or naive ways of explaining oops, that it helps you to break down your large code into smaller pieces of classes or smaller functions, so that like when you have to change something, you don't have to go and find out where to change and like how many times means you have to change. You just go to that specific function that requires the change and change that, and that change will be reflected throughout your whole code. So that's the beauty of oops. Okay, now let us talk about classes and objects. So basically classes are a set of entities, like it has two things, like it has some properties and it has some functions. Now what are properties? So let's take this example called bank account. So bank account here has only one property, that is balance. Means if someone asks that what is the balance of this bank account, so it will return this variable called balance. Okay, so for now ignore this self and all. Okay, so let us talk about simple code. Okay, so let's say for the class we are discussing here has one property called balance. Okay, so which denotes the current balance in the bank account. So what operations can we do in a bank account? So functions basically denotes the operations we can do on that class. So in a bank account we can do like three operations. We can go and deposit money, we can go and withdraw money, and we can check the balance of the bank account. So if we want to deposit money, so let's say we want to deposit a certain amount. So this is a function. Let's say we have a function called deposit, and it takes the amount of money we have to deposit. So our balance gets incremented by amount, right? So similarly, if we have another function called withdraw, and let's say we want to withdraw a specific amount of money, so it first checks that whether we have that, means whether we have sufficient balance to withdraw. If we have sufficient balance, so the balance gets deducted by that amount, and like we get our money. Okay, and the last one is check balance, like where we simply want to know what is the balance of the bank account. So the function check balance returns the current variable, sorry, the current value of the variable balance. Okay, so now so now this is a class. So the class denotes, so the class denotes a bank account. So the class has one property, that is the balance. So it has three operations that can be done on the class. So that is deposit, withdraw, and check balance. So let's say so let's say you, as I was talking earlier, that uh, if any changes are required, so let's say in your code uh, any property of the bank account changes, so you don't need to go and search like where should I change. You should directly come to this class, because this class denotes the bank account, and make the changes here. Okay, so that's the usefulness of oops. So you so whenever you know that the bank account structure has changed, you come to the class of bank account and change the structure of the class. That's it, and the changes will be reflected all over the code. Okay, so now let's talk about what are objects. Okay, so objects are basically like for calling the classes. So this is an object. Okay, so we now want to use the class of bank account. So we have created an object of bank account, and we have started with a balance of 1,000. Okay, so now our balance will be 1,000. Okay, so we have created a bank account by using the class bank account with the initial money of 1,000. So our, so the balance, so the value of the balance will be 1,000, right? Now next we are performing the operation deposit. Okay, so what deposit does, it increases the balance by 500. So now it is 1,500. Next we withdraw. So first it checks that whether the amount is greater than the amount or not. So it's greater than 200, so it does decrease the balance by 200 and becomes 300. So now when you print the check balance, so check balance basically returns the value of the variable balance. So it returns 1,300, and 1,300 will be printed. Okay, so this is basically the structure of like how classes and objects work. So basically you first create an object that is of bank account, and then use the operations according to your needs. So first you, if you need to deposit, you call the operation or function deposit, then you call withdraw, then if you want to check balance, you call the function check balance. As simple as that. Okay, now what is, we will next talk about encapsulation. Okay, so now what is encapsulation? So let's say you are using ChatGPT, okay, but you don't know how ChatGPT is internally functioning. All you know is that you will give an input text and it will give you an output, okay. So you really don't know how ChatGPT works on the inside. So now this is encapsulation, that this code, the code that I highlighted, this code doesn't know how the uh, uh, class bank account operates. Means this highlighted code doesn't know how this code operates, okay. So when we call, means when we use the code from outside the class, okay, so when we use any code outside this highlighted class, so it has no idea that what is going on inside the class bank account and how is it being used and all of that, okay. So when you are calling account dot deposit, so this line doesn't have any information that how the deposit function will work. All it knows, all the line knows, that it will deposit 500 and it will and increase the balance by 500. So it knows this much only, that it will increase the variable balance by 500. It doesn't know how it will increase, or in which algorithm or data structure it will increase. It doesn't know anything. It just knows that my balance will be increased by 500 if I call the function deposit, okay. As simple as that. Similarly, if we call withdraw, that function only knows that it will withdraw 200. Now how it will withdraw 200, how it will subtract, or how it will implement the if else, or how it will check that whether the amount is withdrawable or not, it has no information about that, okay. So now that is called encapsulation. That is code or things outside the class, like piece uh, anything outside the class generally doesn't have any information like how the class works, like how it will function. It only knows that I will give the class this input and the function of that class will give me that output. It only knows that what it can means what it will return if I give input this, okay. So this is encapsulation basically. Now let's talk about inheritance, okay. So basically inheritance is basically inheriting something. It's very similar to the English term of inheritance. Like you inherit the properties of a class here. So like you inherit the property of your parents or something like that. So here the child class inherits the properties of their parent class. So here you can see that there are two classes, like there is a dog class and there is an animal class. So the dog class is the child class, okay. So it will inherit the properties of its parent class, that is animal, okay. So what we do I mean by the properties, it is basically the functions and the data members. So the class dog will be able to use its uh, name, that the name of the animal class, and it will also be able to use the function speak of the animal class, okay. So here you can see that the dog class inherits the class animal, so it takes the means it inherits the class animal. And then here you can also see that it can use the variable name which is a property of the class animal. So the child class can use uh, the properties and the functions of their parent class. Now what is the use of this? So if let's say dog couldn't have used this variable name, okay, if the class dog couldn't have used this variable name for animal, so it would have means the class would have to write the property name again. So duplicate code will be there. Like there is a property name in the animal, also there is a property name in the class dog also, okay. So like it has to write the same code again if it can't use the code from its parent class. So if dog can't use the code or the functions or the properties of its parent class, it has to implement or write those functions and properties again inside itself. So that is duplication, and that is not like encouraged, because that's a waste of everything, like time and resources. So why not inherit the properties of its parent class and directly use them? So dog inherits the properties of the animal class and directly uses its variable name, and it prints that. So here you can see that if we are creating an object of class dog, and we are creating an object of class animal with name buddy. Okay, so when we call this function speak, so it directly takes the name, so the name is buddy from the class animal, and it prints barks. Okay, so the output becomes buddy barks. Okay, so this is basically inheritance. Okay, so the basic thing, or the basic uses of inheritance is to remove the duplicacy of code, and to remove like using same code again and again. Okay, so why you write in means in while you are doing some software development, or you are writing some code while doing an internship or doing a full-time job, is that like you will be implementing uh, inheritance, because like there will be a lot of classes which will use a similar type of code. Okay, so there will be a parent class, and you have to implement child classes of those parent classes, and reuse those functions and properties after deriving them from the parent class. Okay, next we will talk about polymorphism. Okay, so polymorphism is basically like taking various like it is the means taking various forms. Okay, so let's if we create a class, let's say if we create a class. Okay, but we want to use that class in various types of ways. So let's say we create a class called shape. Okay, let's say we create a class called shape, and we want to calculate the area of this shape. Okay, uh, we want to calculate the area of this shape. Okay, so now we have created a class shape. Now there can be various shapes, like let's say there can be rectangle, there can be circle, and others. So if we want to calculate the area of a rectangle, what do we need? We need its length, and we need its height. Sorry, length and breadth. Okay, so we what we can do here is that we can use polymorphism, and we can inherit the class shape from the class rectangle. So let's say we define another class rectangle, and we inherit the class shape, and we take two parameters as its member variables. So one is length, and another is breadth. Okay, so now if we want to use the function area, so we will simply return length into breadth. Okay, so what we have done here is that we have inherited the class shape from the class rectangle, and we have used this function from its parent class just by modifying its member variables. Okay, now similarly, if we want to calculate the area of a circle, we just need its radius. Okay, so we just need its radius, and the function will be pi r squared. So pi into r into r. Okay, so this is the area of circle. So here instead of so here what we have modified, instead of taking length and breadth, we have taken radius. So here you can see that we are inheriting the class shape again, and we have taken the member function radius, and then calculates its area using the function of its parent class. Okay, so here we are using means here we are inheriting the class shape. Okay, but we are using it for different purposes. Sometimes we are using it for calculating the area of rectangle, sometimes we are using the calculating the area of circle. So we are using the same class, and we are inheriting the same class, just we are using different versions of the child class to calculate like various means to solve our various types of problems. Okay, so that's polymorphism in oops. Like you allow objects of different classes to be treated as objects of a super, means common superclass. Okay, so the common superclass here is the shape. Okay, so it is a common parent class or superclass for both the classes rectangle and circle. Okay, but both rectangle and circle does different things. Means it calculates the areas of different shapes, right? So polymorphism is nothing but using the object of a common parent class and using it for various purposes. Like here we have used the object or the function area of the parent class, and we have used it for calculating the area of various shapes like rectangle and circle. Okay, so this is basically polymorphism uh, in object oriented programming. So basically these four topics are quite sufficient for going in for the interviews like of object oriented programming. Just I want to add some things for appearing in object oriented programming, and they are like, always remember that uh, don't write a very big piece of code. Okay, if you write a very big piece of code, there are high chances that the interviewer will reject you. Okay, so try to break down your code into different functions, try to break down your code into different classes. So try to make separate classes where every class has a single responsibility. So let's, here we made a class called bank account. The responsibility of the class bank account is to handle the structure of a bank account. Okay, so try to identify the different structures and put different structures into different classes. Inside classes, try to separate out responsibilities and try to write them in different functions. Okay, and someone asked that what is the difference between a class and a function. Okay, so class is basically a set of member variables and functions. Okay, so here if you see that we have a class called bank account. Okay, so bank account is an entity. Okay, bank account is an entity. Okay, means bank account denotes an entity. Okay, and function is an operation. Okay, so bank account is an entity on which you can perform an operation. Okay, so that's why bank account is a class. And like the operations you have done uh, are called functions. So data abstractions, I told you, like it's very related to encapsulation. Okay, so data abstraction is that, like when we're talking about the code outside the class, that is, we are talking about this code. So this doesn't have access to the data inside the class. Okay, so this piece of code doesn't have uh, access to the code inside the class, right? So it doesn't have any information like how the function is working or things like that. And that generally denotes data abstraction, that any code outside the class doesn't have any low level information. What do I mean by low level information? The low level information is that, like it doesn't know how it is handling the corner cases, how it is, means what data structures are it is implementing, what algorithms are it using. It only knows the high level information, that it only knows that if I call the function deposit and pass some money, it will increase the balance. If I call withdraw, it will decrease the balance. If I call check balance, it will show me the balance. So data abstraction is basically showing the high level information of a class and hiding the low level information. Okay, because if every code knows every details, the code is messy. For example, if a manager in a company tries to know everything, tries to know everything, like he will get puzzled. Okay, so what he does, he tells his employee that you need to do this thing, and I don't care about how you do this thing, you just need to do this thing, means. Okay, so that's the high level information, that the manager knows that this employee will do this thing, he doesn't know how he will do or how he will manage to do. Okay, so that's data abstraction here. Okay, so that's basically is happening here also. Like the outside code snippet knows that bank account will do this, and it is like satisfied with this information only, because that code doesn't need to know how the things are being implemented. So like the data is being abstracted from it. Okay, so these are the four mm, very basic or and very important topics of OOPS. And if I talk about the sources of learning OOPS, so there are scalar interview problems for OOPS. So that is very helpful, and like that's a very good sheet for interviews. I will share the link, or like you will get the link after the session. So scalar interview sheet is very good. Similarly, like your if you should have oops in your college curriculum, okay, so you should pay some attention to that also, because oops is really a very important subject. Like when you are working in a company also, like you will definitely use oops. Like for writing every line of code, you need to understand the concepts of oops. Okay, so in software development, without oops you can't go anywhere. Okay, so that's another thing. So these are the things I wanted to cover in this session. I don't want to make it too big or too large or too complex, because in new grad or internship level interviews, you don't really need much of oops. Just these basic things like encapsulation, inheritance, polymorphism, data abstraction, like how classes and objects are being done, like when you should you means how you should use classes and functions to make your code simpler and more readable. So these are the things that are more than sufficient to like crack your new grad interviews, especially the last round where system design and open-ended questions are there. So that's, I would say, that's all for this session. If you guys have any question, just let me know in the chat. I am waiting for 30-40 seconds maybe, and then we can close the session and move see means we can go and means you can go and read more about oops from the scalar sheet that I told you. And I think that will be more than enough for helping you get through the oops interviews. uh Basically, like, that's a different question, to be very honest, but apply as many jobs as you can, like, and reach out to as many people as you can. That's the only thing. Like, times are tough, but as they say, like, if you keep your skills well, means if you sharpen your skills during these times, you will definitely gives means you will definitely get opportunities after that. The link will be there, like it will be shared after the session, like in the doc which I used today for teaching. In that doc only the link will be shared and it will be given to you, don't worry. So any other questions, or like if you don't have any other questions, we can stop. I guess we don't have any other questions. So that's it for this session. See you in the next session. Till then, try to read more about OOPS, try to see some interview questions, and definitely the sheet will be given to you soon after the session. So that's it for this session. So bye, everyone.